I'm here to talk about the Zero Carbon Australia Station Energy Plan and about decarbonising our economy. The need to go to completely decarbonised economy and actually actively draw down carbon. So there's too much carbon in the atmosphere today, and that's where we're at in 2012. We have been there already. So in order to deal with that, we actually need to zero our carbon emissions and then draw down the excess load in the atmosphere. And that's if you want to de-risk our future as a sort of an agricultural civilization that lives in the current level of harmony we do with the planet, which includes wars and things. So I would hate to see the new level of lack of harmony with the planet if we decide not to deal with this issue. And that didn't work properly. Yeah. Alright, so I'll try it once more. Yeah, okay. So need, I'm going to go through need, technology, reliability, resources, jobs, economics, social and political will, and also alternatives. Ooh. No, we're not doing that way. Okay, great. So next. Okay. Yep, next. So that's the Station Energy Plan. We released that in 2010 all around the country. The organisation's a research and communications organisation. It's completely independent. We use pro bono contributions, staff coordinators, and we run on donations. So we're like an environment group like ACF or Greenpeace, but we have our own in-house research capability and we link that with a number of Australian leading universities, including the University of Melbourne and soon to be a leading Queensland university. Next. So this is the team who did the Station Energy Plan. Includes physicists, mechanical engineers, electrical engineers, chemical engineers, a whole lot of people who work in industry, government, work in regulatory roles, and also they're university students. And so the guiding principles, it's a blueprint for a zero carbon Australia in the decade. We fully accept the latest climate science, specify only commercial off-the-shelf technology, and we want to maintain or enhance Australia's energy supply security and availability, reliability, food and water security, and our standard of living. So it's not about sort of going back to the cave age. Next. So Station Energy Plan's electricity from power stations, so stationary means not moving, so transport would be not stationary, and it's detailed and fully costed model of one scenario of reaching a 100% renewable economy, and we've showed that you can do it in a decade if we wish to do so, and that would be the prudent thing to do if we want to avoid dangerous climate change. Next. It's endorsed by various people, the IEA, General Peter Gratian, former Chief of Defence, Augusta Finossel, and former Australian Chief Scientist Robin Batterham, and about 3 dozen more. Next. So are you confused about that language? Low carbon, clean energy, or zero carbon renewable energy? Are they interchangeable? Have you heard it? You're getting confused. There's two versions of what's out there. Which future do you guys want? Do you want your low carbon or zero carbon? Zero? All right, let's go next slide. So low carbon is gas, not gas. Gas is gas and oil, peas in the same pot. And zero carbon are things like solar thermal plants, wind, rooftop photovoltaic, and so on. Next. Low carbon is reduced emission vehicles, so they still have tailpipes. So there's a theme here. Low carbon is tailpipes and smokestacks, whereas zero carbon is no tailpipes, no smokestacks. So if you get rid of the back. If you get rid of the tailpipes and the smokestacks, then you've got a zero carbon economy, and you can see fast rail, metros, electric vehicles, and so on. Next. Cooking. People get a bit worried, but if you ever use an induction cooktop, far superior to gas. So gas actually leads to some 40% of child burns in hospital admissions, and that's gas for cooking. And also the NOx in buildings is making everybody sick, so it's aggravating asthma and so on. Whereas induction cooktops, you can take the pot off there, put your hand down and not leave your skin behind. That's pretty handy. It reduces emissions. Next. And the low carbon plan is the BP plan, the Exxon plan, the Shell plan. Not only that, Actually, I'll show you the next one. The zero carbon plan is Shirong Shi, who's educated at University of New South Wales and has built the world's biggest solar manufacturing capability. Alois Wobben, who's the 160th richest person in the world, started making wind turbines in his backyard, and about half the wind turbines, and they were small ones, but now half the wind turbines in Germany are made by Enercon, and they're up to 7.5 megawatts, the world's biggest 136 metre hub heights. So it started out like this, and it kind of got bigger over 30 years. Next. The low carbon plan is BP's, and you might have heard this one, the wedges approach, the Socorro Princeton wedges. $30 million from BP and Ford, and another $30 million being written for the next 10 years. So looks like BP, with a problem, are trying to sponsor the solution to be low carbon. So zero carbon is a bunch of volunteers, build zero emissions. We're funded by people like you guys, people who are really interested and keen to get the job done, not by the world's third biggest petroleum company and one of the world's biggest motor companies. Next. Tri-generation, one way go back. We're introducing NOx into the Sydney airshed. It goes against 100 years of cleaning up city air. So ever since the Industrial Revolution, there was some mills and coal being burned in cities. Cars came along and people ran away from the cities and into suburbs. Now then everyone decided we needed to go high density or medium density living again in order to stop sprawl that was destroying peri-urban areas and encroaching on the whole planet, like cancer. So we decided that we'd clean up the air in cities so that they'd be habitable again. If we introduce massive gas burning in cities, then we're going to have a huge nitrous oxide impost, something like 600 to 1,000 tonnes per day, and you're actually doing that where the highest populations in Australia are, so tens of thousands of people frequenting buildings and so on. That's not where to put emissions. Coal seam gas, it's a signal for extraction and it's devastating farmland. It's also not clean. It's got massive fugitive emissions, and in Powder River Basin, Wyoming, we're talking 15% of well yield. So biogas excuse, 250 kilometre radius around Sydney, all available feedstock. Now in addition, cities are using gas for heavy vehicle infrastructure. It's needed for some agricultural machinery and industrial feedstocks most importantly. If we're going to decarbonise the economy, we can't be using oil for making everything. So if we're going to use direct reduced iron to make steel and so on, we're going to need industrial feedstocks. And so we're going to need biomass for that. So this is food competitive. So it competes with industrial processes, transport needs, and you also get nutrient stripping if you then encroach on more agricultural-based feedstocks, which is what you do if you just place all the waste streams with by just using energy, stationary energy, which can be provisioned by electric sources like wind and solar. Then you're doing that. Next slide. So this is a farm. Next slide. And this is a coal mine, and so we're apparently trying to get rid of that. Next. This is a coal seam gas area. Apparently you can use they can cohabitate together, farming and coal seam gas. Next. And this is the current licences in Queensland. Next. So 2,650 wells for the first train. We're talking 10,000 wells over 4 trains. There's a link between getting early access to market via supply into the Australian reticulated DOM gas and then moving to LNG exports. Next. That was the farm from further back. Next. 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 Oh, there's a reverse osmosis plant there. Apparently they cleaned the water up. But we found out that they had one reverse osmosis plant that they use on all the marketing material, but most of the sites don't have a reverse osmosis plant because they're expensive. Next. Next. Oh, yeah, pipelines, lots of those. Next. Next. LNG trains. They're not very good for the Great Barrier Reef. Next. Northwest Shelf. That's current LNG from Australia. We're a big exporter. We're not as big as Qatar, but according to Martin Ferguson, we're going to be bigger than Qatar. Okay? Next. Okay, so bring on the eastern seaboard gas, and you can see it there. It's huge. It's a bit more than double including what's going to expand in WA. So it's gas, 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 gas. Next. Oh, and that previous slide there, I got that from a source. It was meant to be in the Australian Energy Market Operators Outlook, and it got there's a board which is controlled by Origin and so on, and they said, no, we don't want that one in. Next. And this is where the gas exploration licences are, and they're still issuing more. $700 million worth of exploration licences issued in Queensland last year, and they've got a target. It's like a business operation there at government, to sell as many exploration licences as you can. Next. Okay, try again. CSG wells are leaking at 15% of total yield at Wyoming Powder River Basin, US DOE. Unconventional wells, Denver, leaking at a rate of up to 7% of total field yield, according to National Oceanographic and Atmospheric Administration. And they used real atmospheric testing. In Australia, we've had no atmospheric testing, we've had no independent testing, there's no fugitive testing in Australia, zero. And we are expanding at a rate that we're going to be a bigger gas exporter than Qatar. Okay? Gas is dirtier than coal and peaker, CCGTs and trigen plants. Trigen cooling COP is 0.7 versus Japanese variable refrigerant flow HVAC systems, which have a COP of 410%. So you put 1 unit of electricity into them and you get 4.1 units of cooling system-wide across the building using the Japanese system. 1/3 of Japanese large commercial buildings use that system, and about 70% of their medium-sized buildings. Cogeneration is centralised energy. It gets confused for decentralised. It's plugged into the oil and gas industry. There's nothing more centralised in the world than the oil and gas industry. It's dominated by a handful of players, and that's gas, whereas actually electricity is more distributed. When you go renewables, generally the new entrants doing wind and solar and that are all independent power producers. So you want to be on renewable energy. Next. And so this gives you an idea of where they say Trigen is saving 27% on carbon emissions against today's grid. Go next slide. And the next slide shows you where trigeneration is in relation to Australian Energy Market Operators' business as usual potential scenarios for Australian decarbonisation. So if you go trigen, it's in 3 of the scenarios, and these are obviously not radical because they're from AEMO, the grid will actually be less carbon emitting than the trigen units. So if we decarbonise faster than what AEMO is planning, then trigen suddenly becomes the higher vector of emissions on the grid. Next. So develop a station energy plan to show how to do it with renewables. Next. But we're also looking at buildings, and buildings plan is coming out in a month or two, and that'll show you what to do instead of cogen. It'll show you what to do in houses. So in houses, we're going to heat pumps. So air conditioners are actually good if used properly. They're used for reverse cycle air conditioning for heating in the southern states. Queensland's the only place where air conditioning outranks heating for our annual energy demand. In Victoria, it's 82 petajoules of heating and 1.1 petajoules of air conditioning. However, because the air conditioning is turned on for a couple of hours a year, full ball everywhere, we pay X more on our distribution network charges. Now, if cities actually go cogen, that will actually defray more costs on residential consumers in the burbs because of the way the government has regulated paying for the network. So it'll actually increase the per kilowatt hour charges for the people who aren't on the cogen network, because you won't be smearing the cost of network charges across all consumers. The wealthy consumers won't have to pay, and that's your AMPs and so on. Number 3, transport. So we're doing a transport plan. Hopefully the end of this year or the beginning of next year we'll release that. We're doing comprehensive new metros, fast rails and so on, freight and logistics around the country. Land use, we're looking at a plan on how to actually sequester carbon, how to protect biodiversity and carbon value through the Australian landscape, and farming, how to feed and clothe the world to 2050 while achieving that. Next. We'll eventually be doing industrial processes, and we'll be able to show just how much carbon we need in order to process more of our iron ore into steel and other industrial processes, and how to become a renewable energy superpower. So we keep hearing about the golden goose. You'd want it to be 24 karat gold, but I think it's actually laying fool's gold at the moment as the exports of coal and coal seam gas increase the Australian dollar and sell out education, where we have a lot of students now bypassing Australia for places like the US. Manufacturing, where we've lost 127,000 jobs. I'm way behind. Manufacturing, 127,000 jobs. Farmers have lost 30% on their effective income because they're export oriented generally, and the dollar's appreciated so much. So all these sectors are losing. Next. Yep. I'll bypass this. We know 2 degrees is a guardrail. So all those IEA kind of projections are way out. We can't exceed 2 degrees. We need to cease emissions. Next. So the difference between 2 and 4 degrees, which some people have been talking about, is human civilization. Next. And next. So steam generation, you boil water and it drives a steam turbine. Next. And coal mine's bad. Next. Coal plant's bad too. Next. And next. And you can replace the heat source with something else. This is how we do storage, so that variable renewables can be firmed up. Next. Solar thermal plants. And in Spain we've got a plant called Hemasolar. Next. I'll explain how it works. Cold tank full of molten salt. It's industrial fertiliser. Pumped from the cold tank at 209 degrees up to the top of the tower. Receives the light from a sea of mirrors. The salt then gets back in the hot tank. And then when your rooftop PV production is down and wind is down and correlating at the same time, you can take the banked hot salt in the hot tank, like a thermos flask, run it past a heat exchanger, water runs past the other tubes of the heat exchanger, flashes to steam and drives the same steam turbine that's in a coal plant. Next. And that's a mirror, and you have 2,500 to 17,000 of those. And if you stand in front of that and the light gets you, it burns your face, one mirror. But there's 17,000 of them concentrated at the top of the tower. Next. Like that. And that's how you get a firmed up 100% renewable energy economy. You can use wind off the shelf, commercial, available now, solar, rooftop solar, which you're all, I'm sure, participating in, and solar thermal storage as the firming power. Next. So I took Tony Windsor and Ross Garneau to see them to make sure that they knew what they were advocating for. Next. And yeah, just a reminder about the coal plant. Next. Next. Yep, that's what the potassium nitrate looks like. You wouldn't want to eat it. It'll be very unhealthy, but you could lick your fingers. Next. And there's the tanks that hold the molten salt. So they're the same as tanks. Next. In a petroleum plant, only you don't have petrol in them, you just have one charge of salt in them and you reuse that for the next 30, 40 years. Next. That's the solar thermal plant operating in Spain between Cordoba and Sevilla. Next. And that's it operating some more. Next. And this is a bigger one, 110 megawatts that's under construction. I've got a new photo coming. They've got some mirrors down. It should be finished by next year. And it's 110 megawatts. In our plan, we show a scale up. This is the first part of it. We build 12 plants at that size, and then they build 220 megawatt plants. So what's happening internationally as well, in step with what we're saying, a whole lot of people poo-hooed us and said, oh, that's rubbish because they don't exist. Well, they're getting built thanks to Obama. Next. So there's 17 gigawatts under development. Next. And I'm cheating, but I did that. I put it through 25 minutes. So we've got some of the best resources in the world. Next. And here's an example in Spain is as good as Mildura, pretty much. And everything north of Mildura is kind of better in terms of our solar resource. For wind power, would you believe it's buy one, get one free? We put one wind turbine in, we get twice the electricity out as what they get in Europe. And they're willing to pay for twice as many turbines. And we have whingers here in Australia whinging away, saying it's too expensive to spend wind turbines, install wind turbines. Next. All right, we'll stop here. About 20 slides short. So 20 tonnes of coal or 1 square metre of mirror. So it's our choice. We can install the renewables or we can burn the coal. And gas is a diversion, not a shortcut. The oil and gas industry are the guys who sponsor climate denialism even more than the coal industry. Like if you look at all those think tanks in the US, like your Heartland Institute and everything, all the money goes back to BP, Exxon, and so on. It doesn't go back to the coal companies even. So don't think that the gas guys are delivering your solutions to climate change, because they're not. Thanks.